Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at our Chapter 9 test review, so we'll get started right away. The first few questions are going to be all right angles or all right triangles, and to find missing lengths, we can use the Pythagorean theorem of a squared plus b squared equals c squared. Okay. For this first one, I'm missing a leg, so I'll just call that a, so I'm given a b and a c. So I'm going to take my 11.1 squared, which is 123.21, and my 4.4 squared, which is 19.36, and I'm going to subtract. Okay, I'm going to get 103.85, and then I'll take the square root of that. So x is equal to about 10.2 yards. Okay, for number 2, I'm given both legs, so I can take 11.7 squared and 4.7 squared, add them together, and that'll help me with c squared. 11.7 squared, I'm getting 136.89. 4.7, I'm getting 22.09. Those added together, I get 158.98. Will give me x squared, so I just find that quick square root. X is about 12.6. 3, again, we're given the hypotenuse and a leg, so I'm going to take 13.7 squared and subtract 4.8 squared, and that'll give me my x squared. 13.7 squared is 187.69. 4.8 squared is 23.04. That's going to give me about 164.65. So I'm taking the square root of that, and I'll come up with x is about 12.8. And then 4, again, I've got c squared and a leg, so 11.2 squared minus 9.3 squared equals x squared. 11.2 squared is 125.44. 9.3 squared is 86.49. Sorry for the bells. Those subtracting are going to give me around 38.95. And then just finding the square root of that, I'll get about 6.2. Okay. State if each triangle is a right triangle. All we have to do is figure out if I can use this in the Pythagorean theorem. So I'm just doing a and b, my two smallest ones. C is my largest one. So here is 19.5 squared plus 40 squared equal to 45.4. 19.5 squared is 380.25. 40 squared is 1600, and 45.4 squared is 2061.16. So this is no. For my number 6, 10.2 squared plus 28 squared should be equal to 29.8 squared. And 10.2 is 104.4, or 04. 28 squared is 784. And 29.8 is 88.04, or 888.04, and that is right, so yes. Okay. State if each triangle is acute, obtuse, or right. So this is where we have a squared plus b squared, and if it is greater than c squared, then we could say acute. If a squared plus b squared is less than c squared, meaning c squared is larger, then it's obtuse, and then right is just equal. So for this first one, we take 16 squared plus 16.8 squared, and then equals 26.8 squared, or not equals, but we don't know yet. So that's 256 plus 282.24 is what to 718.24. We get 538.24. That's going to be less than 718. So since c is more, we're going to say this is obtuse. Okay. For this one, 48 squared plus 36 squared is what to 60 squared. Our 48 squared plus 36 squared is 3600, and 60 squared is also 3600, so since they're equal, we can say they are right. Same thing here for number 9, 5.2 squared plus 42 squared is what to 42.5 squared? We're going to get 1,791.04, but that'll be less than the 1806.25 that we get here. So we'll say this is obtuse. And 10, we have 12 squared plus 25.8 squared is what to 31.2 squared. Again, this a squared plus b squared is going to be smaller. We get 809.64 is less than 973.44, so that one would be obtuse as well. Okay, flipping on over to number 11, find the missing side lengths. Leave your answers as radicals. Since we have a special right triangle here with a 30, 60, 90, that, remember, we can say the shorter leg is x, the hypotenuse is 2x, and the longer leg is x times square root 3. So what I would just do here is try to make those equal. In this case, y is going to be equal to 7, because if you notice, x and x are matching here. So since y is equal to 7, then I just multiply 2 times that to get x, so x should be equal to 14. Okay? Again, 30, 60, 90. My shorter side is just an x. My longer side is x square root 3. And then my hypotenuse is 2 times the leg. For this one, my 2 times x, which would be 2y, will be equal to 6 square root 3. So I'm going to say 2y can be equal to square root 6 over 3. And how I would solve for that is I would divide both sides by 2 or multiply by 1/2. So I'm going to get y is equal to square root 6 over 6. And then x, because I know that that is now equal to that, I'm going to plug that in here. So x can be equal to the square root of 6 over 6 times the square root of 3, because I'm multiplying by the square root of 3, whatever x was. So I'm going to get square root 18 over 6, which can be reduced down to 3 square root 2 over 6. And then 3 and 6 can be simplified, so I just get square root 2 over 2 for my x. Okay. Again, we've got now 45, 45, 90s. So because those are special, we have my legs are the same, so they both are equal to one another. So y is equal to 7 square root 2 over 2. But my x will be, or my hypotenuse should be x square root 2. So whatever x would be, that is what I can solve for. In this case, x can be equal to 7 square root 2 over 2 times 2. So that would be 14 square root 2 over 2, which just simplifies right down to 7. Sorry, I messed up there. 7, here we go. We're multiplying by the square root 2. So we get 7 times 2 over 2, which is just equal to 7. So x equals 7 here. Okay. Again, 45, 45, 90. V would be the same thing as the other leg, so 9 square root 2 over 2. And then to find my hypotenuse, I do 9 square root 2 over 2 times the square root of 2. That's just going to give me 9 times 2 on the top over 2, which is 18 over 2, which just again then gives me 9. So u is equal to 9. Okay. Find the missing lengths indicated. This is for section 15 through 18. Leave your answer in simplest radical form. So I'm just going to think about this one as, here's my 16, because 25 take away 9 is 16. And I'm going to set up my proportion as x over 16. So that's short leg to long leg. And then for my larger triangle, I want you to think about 9 is my short leg. x is my long leg, okay? So I'm getting x squared is equal to 16 times 9, that's 144, so x has to be 12, okay? For this one, it would be helpful to go ahead and find this entire length. That's 100, because now I'm given my hypotenuses for these. So if I compare x over 36, that's hypotenuse over leg, then I can do the same thing here. Hypotenuse 100 over leg x, okay? So I'm going to get x squared is equal to 3600, so that means x should be equal to 60. 17, we want to maybe think about using the smaller triangle, leg to leg, so x to 12, and then for my next one, I can just use 12 to 16. So I just did short leg to long leg, short leg to long leg, okay? I'm going to get 16x is equal to 144, so that means x has to be 9. And then for 18, maybe I start with comparing x to 60. So x and 60 are a part of my larger triangle. X was my hypotenuse, and 60 is showing that it's going to be a leg. So then for my smaller triangle, comparing hypotenuse, which would be 60, to leg 36, okay? So 36x is equal to 3600, so that means x is equal to 100, okay? Now we're going to get into some cosines and sines and tangent. Find the value of each trigonometric ratio. 20 just ended up being kind of weird. This one's number 20. So for number 19, the cosine of A, cosine is adjacent over hypotenuse. So that's 10 over 26, which reduces to 5/13. The tangent of A, that's opposite over adjacent. So 30 over 16, which just reduces to 15 over 8. Okay? Typing these into your calculator, for number 21, the sine of 45 degrees is 0.7071, rounded to the nearest 10,000. That's 4 decimal places. And then the tangent of 28, I'm getting 0.5317, rounded. Okay. Next up, we're going to be able to use the sine ratios, cosines, or tangent ratios. So in this case, I'm given this is 74 degrees. I'm having opposite over hypotenuse, which is your sine. So we can use sine of 74 degrees is equal to x over 20. I'm essentially just multiplying 20 and sine of 74. I'm going to get x is about 19.2. For here, 49, I'm given opposite over hypotenuse again, so that's sine of 49 degrees is equal to x over 11. Again, multiplying 11 and 49 of the sine, I'm going to get x is about 8.3. These are rounded to the nearest tenth. 25, 36 degrees, I have an opposite and the adjacent, so this is tangent of 36 degrees is equal to x over 19. Again, just multiplying tangent 36 times 19, I'm getting x is equal to about 13.8. 26, I'm also going to use tangent, opposite over adjacent. So tangent of 20 is equal to 16 over x. The first thing I do is I rewrite this so x is on the top, so multiplying both sides by x, I get x times the tangent of 20 is equal to 16. And then I'm going to divide both sides by the tangent of 20. So 16 over tangent 20. And that's going to give us roughly 44.0 degrees. Okay. Next up for this 15, I have opposite over adjacent. So this is another tangent. So tangent of 15 is equal to x over 17. Again, just multiplying 17 times tangent of 15, I'm getting x is 4.6. 28. Here's my angle. I'm getting opposite over hypotenuse, that's sine of 24, is equal to x over 20. Multiplying 24 sine times 20, I'm getting x is about 8.1. Find the measure of the indicated angle to the nearest degree. So this is where we're going to do the inverse. For this angle, I have the opposite to adjacent, so I'm going to find the inverse tangent of 35 over 40, which is going to give me about 41 degrees. Nearest degree means whole number, okay? Again, for this one, question mark opposite over hypotenuse, so that would be the inverse of sine of 21 over 52. We're getting about 24 degrees. For my 31, opposite over adjacent, so tangent inverse of 13 over 48. I'm getting about 15 degrees rounded to the nearest degree. And then for 32, adjacent over hypotenuse, that's cosine of inverse 53 over 55. And I'm getting about 15 degrees there as well. Okay. That's going to conclude your section on printed paper. I do have a few more questions if you want to check out the textbook, page 522, trying numbers 38, 42, 44, and 46. We'll go over those in class so you can see what those look like. Thanks for tuning in, and I hope this video helps you study for your Chapter 9 test. Have a great day.